the S, P, D, and F block elements. The periodic table is divided into 4 blocks: S block, P, D, and F. The blocks correspond to which energy sublevel in the element is filled or partially filled with valence electrons. As we know that we have 4 sublevels, which they are S, P, D, and F. The periodic table is divided into these sublevels, okay, as you see in this periodic table. The yellow for group 1, 2, they are S block, this is B block, D block, and F block. Now let's start by S block elements. The S block consists of a group 1 and 2 and the element helium, so you have to memorize that S block consists of a group 1 and 2 plus what? Element helium. All the elements in group 1, all the elements in group 2 and helium, they are consist what? S block. Group 1 elements have partially filled S orbitals containing 1 valence electron and electron configuration ending in S1. As we said before, group 1 element, they are partially filled S. What do you mean of partially filled S? As we know that S block, it can fill by 2 electrons. Yes, elements in group 1 ending with what? With S1. So we have only 1 electron in orbit in sublevel S. That means they have partially filled S. So group 1 elements have partially filled S orbital containing 1 valence electron and the electron configuration ending with what? S1. Group 2 have completely filled S. What do you mean of completely filled S? Means S, it's totally filled by 2 electrons. So filled S orbitals containing 2 valence electrons and electron configuration end in S2. Because S orbital hold 2 electrons at most, the S block spans 2 groups. As we said before again, S block hold only 2 electrons. Okay, so that's why it spans for 2 groups. So this is for S block, group 1, group 2 plus what? Helium. Okay, this is for S block. Now P block. After the S sublevel is filled, the valence electrons next occupy the P sublevel. Okay, so after we filled what? The S level, the next sublevel what? Is P. So the P block is composed of a group 13 through 18 and containing elements with filled or partially filled p orbitals. So group P from group 13 to group 18, all elements from group 13 to group 18, they are what? P block, and they are filled or partially filled of p orbitals. So we know that p orbital, it has how p sublevels, it has only 3 orbitals. Okay, since it has only 3 orbitals, so it can fill how many electrons? 6 electrons. Okay, that's why from 13 to 18, yes, that's why from 13 to 18 we have 6 groups: 13, 14, 15, 16, 17, and 18. 6 groups because it has 6 p sublevel. It has 6 orbitals, 3 orbitals, and it can hold 6 electrons. There are no p block elements in period 1 because the p sublevel does not exist of the first principal energy level in 1. As we know that the energy level sublevel P we don't have in the first period, because the first sublevel n equal 1, it has only S. So P start from which sublevel? From sublevel 2, from n equal 2, because in n equal 2 we have S and P. sublevels. Okay, that's why there are no B block elements in period 1, because as we said that B sublevel does not exist for the first principal energy level in equal 1. The first B block element is boron B, which is the second in the second period. So B sublevel start from the second period. The B block spans 6 groups. Again, as I said that it spans 6 groups because the 3 B orbitals can hold a maximum of how many electrons? Of 6 electrons. The group 18 elements, which are called the noble gases, as we know that group 18, we called them before as what? Noble gases, are unique members of the B block. They are unique of the B block. The atoms of these elements are so stable that they undergo virtually no chemical reactions. The electron configurations of the first 4 noble gas elements are shown in the table 4, as we will see. So here both the S and B orbitals corresponding to the period's principal energy level are completely filled. The arrangement of electrons result in an unusually stable atomic structure. Together, the S and P block compress the representative elements. So, as we see in this table, the energy level of this table, as we know that the energy level of an element's valence electron indicates the period of the period table in this table. As you see, these are the noble gas notation for some elements, okay, containing S and B sublevels. So again, these are the groups for what? For P level, sorry, P sublevel, which is start from group 13, 14, 15, 16, 17, and 18. So as you see here it has 6 groups because B level, it can hold at maximum